Okay, so here we're looking at the equality of complex numbers. Okay, so i.e. when one complex number is equal to another complex number. So for example, obviously if I say here that a plus bi is equal to 2 plus 3i plus 7i minus 1. We know then that a plus bi would be very simply equal to 2 minus 1 is 1, 3 and 10 is 7, so that'll be 10i. So then we can clearly see that a must have been 1 and b was equal to 10. Okay, so that's just a very simple example that you would know already. So just to keep in mind the usual things we need to know. Okay, so the first thing here is when I squared appears, we're going to change it to minus 1. If a number is completely real, that means the imaginary part, i.e. the I part here, is 0. If the number is completely imaginary, the real part here is 0. So it'll only have a bi part. Now, if you're asked to solve an equation for z, now z or w or some other letter, when they're complex numbers, we tend to use letters at the big, like z and w. When they're real numbers, we tend to use x and y. Okay. Right, so if we just follow through on with this example, it says find the complex numbers w such that w times w bar, or the complex conjugate, minus 3i times w bar or conjugate are equal to 5 times this. Okay, so let's have a look at what we do here. Now the first thing is very important from step 4. If you're asked to solve an equation for z, so we're asked to solve for w here, but we must remember that w is actually in the form a plus bi. It's really important that we do that, because if we don't do that, we're going to only solve for one of the two, the a or the b. We need to solve for both of them. Okay, so then I'll write down w here in my first equation is a plus bi. The conjugate w bar is a minus bi minus 3i times w a minus bi is equal to 5, well, let's just multiply this out, which is 35 minus 15i. Okay, now, so we need to multiply all out and put all real parts together and all imaginary parts together. Okay, so this one here is the difference of two squares again. Now remember, the quick way when you're doing complex numbers for this will be a squared plus b squared. So that's going to take care of that part. Okay, now we're multiplying minus 3i by a, so minus 3ai, and minus 3i by minus bi is plus 3bi squared, equal to 35 minus 15i. Now the next thing we do is we make sure and get rid of any I squareds and put them equal to minus 1. Okay, so this line was skipped in the notes, so we'll just go to the next line that's in the notes. Says a squared plus b squared minus 3ai minus 3b. Okay, so I'm after converting that I squared into a minus 1, which makes that positive become a negative, equal to 35 minus 15i. Now the next thing then we do is we pick out everything that's real and we put it equal to everything on the other side that's real. We pick out everything that's imaginary and put it equal to everything on the other side which is imaginary. So looking along, very easy spot if it's real, it will have no i's connected. So those three terms there are real on the left, and this is the real on the right. Then for imaginaries, we have minus 3ai here, which is imaginary, and we have minus 15i here, which is imaginary. Okay, so reals then is going to give me a squared plus b squared minus 3b equal to 0. Now my imaginaries then, now notice when I'm writing down my imaginaries, I don't need to write down the i's, and the reason for that, I've already labelled them that they're imaginary. We only need the i's when they're mixed up with reals because we get confused. But here I'm only looking at imaginaries, so there should be no confusion. Okay. Now we have simultaneous equations here. We have two unknowns and we're trying to solve them, but we should be able to see from here what a is. So obviously we see that 3a is equal to 15. So a is equal to 15 over 3, which is 5. Okay, so now we can go back into this more difficult equation over here and fill in what that 5 is. So that means we're going to get a squared. Oh no, sorry, we know what our a is now at this stage. So a is 5 squared plus b squared minus 3b equals 0. So this is 25 plus b squared minus 3b equal to 0. So b squared minus 3b plus 25 is equal to 0. Now all I was doing on this line was I'm realizing that this looks like a quadratic equation, and that's exactly what I do. Writing it in the form ax squared plus bx plus c equal to 0 to allow me to solve it. Okay. Now the next thing I need are the factors of, sorry, is that a 25 or sorry. Now let me just go back up here. I just realized I'm after putting this equal to 0, but it wasn't 0. It's actually 35 on that side. Okay, so this here should be equal to 35. And this should equal 35. So that will mean my equation here should actually be minus 10 equals 0. Okay, so sorry, I forgot to put in that 35 from the right hand side. Okay, so again, now we have to solve this. So I have my 5 and 2. So remember, I'm looking at my factors of 10 that are going to give me add to give me the middle one, which is 3. Now I need a negative 3, so that means I need more negatives than positives. Okay, so I need that many negatives, that many positives. So that means then I'm going to have that b is equal to negative 2 or b is equal to 5. Okay, so there's my two complex numbers. Now note there's a mistake in handout, because I think in the handout they're both, wait till I just try and have a look here if I can at all. Okay, I think on the handout they're both, I can't find it here now, but they both, I think they're both positive in the handout. Okay, so my numbers are then, my numbers are in the form a plus bi. So that means it's 5 minus 2i or 5 plus 5i for my two complex numbers. And it did say in the question that find the complex numbers, so there was going to be two of them. So even when you see that at the start, it's important to realize I must be going to solve a quadratic equation somewhere, because quadratic equations lead to two answers.